This is Brian Fox. I'm a research statistician here at nQuery, and in this video, I will just demonstrate how to calculate the sample size for group sequential design within nQuery. I will show you some of the group sequential design methods available within nQuery and why they can be so powerful in clinical trial designs. Group sequential trials can greatly reduce the expected sample size and calendar time of clinical trials. For example, a group sequential design with a single interim analysis can reduce the number of subjects required in the trial by roughly 15% relative to a comparable fixed-term trial. In the example to come, we will see how the expected sample size is greatly reduced from the fixed-term value of 266 to approximately 170 under the null hypothesis, or approximately 209 under the alternative hypothesis. A group sequential design is just a type of trial design which facilitates interim analysis, which is to say that data from the trial is analysed at pre-specified interim points while the trial is still ongoing. At these interim analyses, certain decisions or modifications can be made, for example, stopping the trial early for efficacy or futility, or adjusting the sample size. So why are these designs so useful? Well, one of the main advantages of these types of designs is that they facilitate earlier decisions to be made in the trial. This allows drugs or treatments which have shown efficacy to be provided to patients sooner, and drugs or treatments which have shown futility to have the trial stopped, allowing resources to be allocated to other, possibly more efficacious treatments. A resulting benefit of this is that it can significantly reduce the expected cost of the trial, where the expected sample size can be reduced compared to fixed-term trials. It also gives the trialist more control over the trial and allows interim assessment of how the trial is progressing. If sample size re-estimation is used, this may also allow drugs or treatments which have clinically relevant effects, but which are lower than expected at the design phase, to be kind of saved from failing to find for efficacy due to insufficient power. Let us now explore this within nQuery. This is what our expanded group sequential design tables look like in nQuery. And for our example, we will be assuming a test significance level of 0.025, one-sided test, 4 looks in total, a group 1 mean of 0.3, group 2 mean of 0.1, and common standard deviation of 0.5 and 0.5. So then we come to these two parameters here. These are essentially our boundary calculation methods for both our efficacy and futility bounds. We can see that there are multiple different methods available here, and a summary of these methods and their benefits is provided in our technical manual, which is available here under the Help menu. In our example, we're going to assume that we'll be using the Lan-DeMets error spending function, which is this option here, for both the efficacy and futility boundaries. Once these have been chosen, we can see that below here, 2 tables appear. So the number of looks has been specified. On the left, we have our group sequential trial parameters table, which is essentially a summary of the parameters relating to the boundary calculation methods chosen. So here we must specify our alpha spending function. A list of different spending functions is provided, and each of these spending functions has been described in detail in our technical manual. So here we're going to use the O'Brien-Fleming spending function for both the alpha and beta spending functions. We are also going to assume non-binding futility boundaries, and we're going to assume that our boundaries will appear on the Z scale. On the right, we may choose our group sequential trial outputs. So here we have our information time, which we will assume here to be equally spaced, which is the default, and we can choose whether or not to stop for efficacy or futility at each of these looks. So then, once they have been specified, we can return and enter in our power and sample size ratio, and we see that we get a group 1 and group 2 sample size of 143, which is an increase of 10 based on an equivalent fixed-term trial with the same parameters. So an increase of 10 per group, I should say. However, we can see that if we go to our group sequential trial report, which is just here, expected sample size is 208.5 under the alternative hypothesis, which is a very large reduction compared to 266 in the equivalent fixed-term trial. And also, in the case where the null hypothesis is true, we can see that our expected sample size is only around 170. And so this shows the power of a group sequential trial in terms of reducing the expected sample size and also the time allocated to a trial. Additionally, we have also got our two plots here. The first being our boundary plot, which is a summary of our group sequential trial boundaries at each of the looks. And then we also have our error spending plot, which shows the alpha and beta errors spent at each of the different looks. In addition here, we have our group sequential trial simulation button, which once clicked, brings up our group sequential trial simulation tool, which will inherit any of the relevant data from the original example that we have ran, which is this example here. So this tool allows one to explore different design characteristics of a group sequential trial and how changing them can affect the trial. For our example, we will just assume the defaults from our original example, and we can specify how the standard deviation is to be calculated. But a lot of this has been covered in our most recent webinar, so I won't go into detail here. And you can see that once ran, we see that our power is very similar to what we'd expected of 90.2 in our original example. And also we can see that the expected sample size is the same almost as the average sample size under the alternative hypothesis. Okay, so that has hopefully given you an idea of what basic group sequential design calculation is like within nQuery and how to navigate some of the resulting outputs, these types of designs. Thank you.